Okay, so welcome to another lesson. So for this video, we will be discussing rationalizing substitution. So rationalizing substitution is like algebraic substitution. Okay, so it's basically just algebraic substitution, but it is quite special because in this type of substitution, we are going to rationalize. Okay, we are going to rationalize the integrand. Okay, so when we say rationalizing the integrand, so we will get rid of the radicals. Okay, so usually in rationalizing substitution, so it can be considered as rationalizing substitution if we have two or more orders of radicals in the integral sign. Okay, so as you can see, so similar with our example, so we have, for our example, evaluate the integral of dx over square root of x plus cube root of x. Okay, so you have two orders, two indices or index of our radicals. So we have an index of 2 for the square root and an index of 3 for the cube root. Okay, so basically, so for rationalizing substitution, we will substitute a value. Okay, we will substitute a new variable in such a way that when we substitute the new variable, we can get rid of the radicals. Okay, so in assigning our substitution, in selecting what would be the value for our substitution, so we must first look at the radicals. So we have square root here and we have cube root here. So one technique is first we need to express the radicals in their exponential forms. So this will become integral of, so changing the radicals into exponents, so we'll have dx over x raised to 1/2, okay, plus x raised to 1/3. Okay, so the next thing that we'll be doing is we will express the fractional exponents, okay, in terms of the same denominator. Okay, so we will express again, we will express 1/2 and 1/3 in such a way that they will have the same denominator. Okay, so one way to do that is to find the least common multiples of the denominator, okay, or the least common denominator. So the LCM of the LCM of 2 and 3 is 6. Okay, so we need to express 1/2 where its denominator is 6, and also we will need to express 1/3 for which its denominator is also 6. Okay, so we can say that it's equal to x raised to 1/2 is also equal to x raised to 3 over 6, right? Plus, for this one, x raised to 2 over 6. Okay, so they now have the same denominator. Okay, so notice 3 over 6 is still equal to 1/2, and 2 over 6 is still equal to 1/3. Okay, so to eliminate the denominator 6 in the exponent, we will now introduce a new variable to for us to use in the rationalizing substitution. Okay, so if we let let's say u is equal to x raised to 1 over 6. Okay, so as we can see, this is also equal to integral of, so let's write it first before substituting. So x raised to 3 over 6, that is equal to x raised to 1 over 6 cubed, right? Plus x raised to 2 over 6, that is equal to x raised to 1 over 6, and then squared. Okay, so if we let u as x raised to 1 over 6, so therefore this will now become integral of, the denominator will now become u cubed, okay, plus u squared. Sorry, u cubed plus u squared. Okay, so since we let u as x raised to 1 over 6, okay, here. So on the numerator, we will also express x in terms of u. So from here, if we let u as x raised to 1 over 6, so raising both sides to 6, so we will see that u to the power of 6 is equal to x. Okay, and differentiating both sides, we can also see that, so differentiate u to the 6, that is using the power formula, so 6 u raised to the power of 5 du, okay, so that is equal to differential of x, so dx. Okay, so therefore our dx here in the numerator will be replaced by 5u to the 5th, 6u to the 5th du. Okay, so the next is, as you can see, the numerator, the degree of the numerator is 5, and then the degree of the denominator is 3. So therefore we can use division. Okay, but first let us first what do you call this? Let us first factor. Okay, so here we can see that we have a greatest common factor of u squared. So therefore it's equal to integral of 6u to the 5th du, okay, over u squared times, so factoring u squared from here, factoring u squared from u cubed, so what will remain is u, and then here factoring u squared from u squared, so that what will remain is 1. Okay, so we can still simplify it. So integral of, we will have 6, so we can cancel u squared, so what will remain in the numerator is u cubed, so 6 u cubed du, okay, over u plus 1. Okay, so as I was saying earlier, so the numerator has higher degree than the denominator. The numerator is, its degree is 3, the denominator, its degree is 1. So therefore we can perform division. Okay, so if we divide, so let's just divide it here. So u cubed divided by, so divided by u plus 1. So u cubed divided by u, that is u squared. U squared times u, that is u cubed, plus, multiply u squared times 1, so plus u squared, and then subtract. So u cubed minus u cubed, that is 0, and then we have here, bring down, so we have here 0, right, so plus 0. So 0 minus u squared, so that is negative u squared. Okay, and then u squared divided by u, so that's minus u, times negative u times u, so that's minus u squared, negative u times 1, that is negative u, and then subtract again. So negative u squared minus negative u squared, so that is 0. And then we have here plus 0, so 0 minus negative u, so that is positive u. Okay, and then divide again, u divided by u, so that is plus 1. 1 times u, that is u. 1 times 1, that is plus 1. And then subtract. So we will have a remainder of negative 1. Okay, so therefore u cube over u, okay, u cube over u, that is equal to u squared minus u plus 1, and then minus 1 over u plus 1. So you are wondering why we didn't include 6, because 6 is a numerical coefficient. We can take that out later on we can take that out of the integral side. So we have 6 integral of, so the quotient of u cube over u plus 1 is u squared minus u plus 1. Okay, and then minus 1 over u plus 1. And then write the du, and then du. Okay, so once we have that, so we can now integrate with respect to u. So we'll have 6, so open bracket, so integral of u squared du minus, we have integral of u du plus, we distribute the integral sign and 1, so plus integral of du, and then minus integral of, so distributing here, it will become du over u plus 1. Okay, so integrating, so we'll have 6 times integral of u squared du, so using the power formula, that will become u raised to 2 plus 1 over 2 plus 1. So u cube over 3, okay, minus, so this will become, we have our exponent is 1, so u raised to 1 plus 1 over 1 plus 1, so that will become u squared over 2, okay, plus here we'll have integral of du is u minus integral of this is natural logarithm, so where our numerator is the complete differential of the denominator, so no need to add any constants whatsoever, so minus ln of u plus 1. Okay, so since we finished integrating, so don't forget plus c. Okay, so let us distribute 6. So this will become 6 times 1 over 3, that is 2 u cube minus, so minus 2 times 1 half, so we have 3 u squared plus 6u minus 6 ln of u plus 1 plus c. Okay, so we now finish integrating. Then let's return the integral into the original variable. So we substituted earlier u is equal to x raised to 1 over 6. So therefore, since u is equal to x raised to 1/6, therefore this will become 2 times x raised to 1 over 6 cube minus 3 times x raised to 1/6 squared okay, plus 6x raised to 1/6 minus 6 ln of x raised to 1/6 plus 1 plus c. Okay, so we can simplify this. So x raised to 1/6 cubed, that is equal to x raised to 3/6, and 3/6 is equal to 1/2. So that is 2x raised to 1/2 minus, we have 3x, so 1/6, 1/6 squared, so that is 2/6, or that is 1/3. Okay, plus, copy the rest, so 6x raised to 1/6 minus 6 ln of x raised to 1/6 plus 1, okay, plus c. Okay, so we have this as our final answer. Okay, so you can also return the final answer into its radical form. Okay, since the given is in radical form, so you can also express your answer in radical form. So in radical form, you will have 2 square root of x over here. So 2 square root of x minus 3 cube root of x plus 6 root of x minus 6 ln of 6 root of x plus 1, and then plus c. Okay, so that's how rationalizing substitution works. So as you can see here, if we didn't use rationalizing substitution, so it will be very difficult for us to integrate this one. Okay, so the beauty of rationalizing substitution is it gets rid of the radical. Okay, so where you can integrate it simply using algebraic manipulation. Okay, so that's it.